seniors, welcome to our last day of benchmark review. Super excited. I think we're gonna crush this test. Can't wait to celebrate with you guys when you do. Today's gonna be just a big mixed review today. There's not like one skill we're working on. There's gonna be a whole bunch of things. So make sure you take really, really good notes today. We're just gonna jump in. Our first example is actually gonna be just solutions to systems of equations. I just wanna remind us how to do this so we do this super strong on our benchmark. So when I'm talking about a solution to a system of equation, I'm talking about an ordered pair, a coordinate pair, that works for both equations. So what I need to do is plug in these values into both of my equations to figure out which one makes both of them true. So let's go ahead and do that. So go ahead on your notes page, go ahead and write our equation, which is x equals 2y minus 8, and our second equation is 4x plus y equals 13. Now again, all I'm doing is I'm taking these solutions and I'm plugging them in for x and y. So let's do the first one. My first answer choice is 2, negative 5. 2 is my x value, negative 5 is my y value. So I'm going to plug in 2 for x in my first equation. And then I'm going to plug in negative 5 for y. So now all I have to do is simplify this down. 2 equals 2 times negative 5 is negative 10, minus 8, I'm going to be left with 2 equals negative 18. 2 does not equal negative 18, so I know that this first coordinate pair will not work, is not a solution for both of my equations. If it doesn't work for the first equation, don't even bother plugging it in for the second one, because it won't make it any more true. Alright, my second one is going to be negative 2 and 5. Again, negative 2 is my x value, 5 is my y value. Let's just plug it into the first equation. I have negative 2 equals 2 times 5 minus 8. Now again, I want this side of my equation to equal negative 2. I'm just going to bring negative 2 down. I'm going to have 10 minus 8. That's going to leave me with negative 2 equals 2. Negative 2 and 2 are not the same. Shavance, they are not the same. This is not the correct answer. Let's plug in our third one. Alright, answer choice C is 2 and 5. 2 is my x value, 5 is my y value. Let's plug it in for our first equation, which is, again, this one. So I have 2 equals 2 times 5 minus 8. That's going to be with 2 on this side. 2 times 5 is 10. And then I bring in my negative 8. 10 minus 8 is going to leave me with 2. And since I have 2 on both sides, this answer, 2, 5, works for our first equation. I need to plug it into the second equation to make sure it's true. Make sure you make the effort to plug it into the second equation or it may not work. Alright, so again, I'm just going to plug in x and y into my second equation. So I have 4 and 2 plus 5 equals 13. 4 times 2 is 8. Bring down my 5. 8 plus 5 is indeed 13. So since this solution set works for both of my equations, C is going to be my answer. Alright, here I'm given a graph and a table, and I want to compare them. And my question here is, who is saving more money each week? How do you know? What I need to do is write an equation, because my slope will tell me which one is saving at a faster rate and why. Alright, so if you can't read this table, this is 1 week for $1.75, 2 weeks for $3.50. At the third week, she saved $5.25. The fourth week, she saved $7. What I need to do is write an equation for my graph and my table. Let's work with the graph first. Well, I can already go ahead and see that my y-intercept is going to be at 0. So I already have half my equation right there. What I need to do is go ahead and find the next clear point, which is right here at 2 and 1. I'm going to go ahead and find the rise and the run, which is 2 over 1. So I'll have a slope of 2. So my equation for this graph is going to be y equals 2x plus 0. Now, we need to make sure we understand what that means. What that means is that for every 1 week, Antoine is saving $2. So let's see if that's true, which means that 2 weeks, he should be at $4. Yep, that's true. At 3 weeks, he should be at $6. So every week, he's saving $2. All right, let's see how fast Carla is saving money. what I need to do is write an equation for my table, change in y over change in x. So I'm going to have 350 minus $1.75 over 2 minus 1. 350 minus $1.75 is going to leave me with $1.75. 2 minus 1 is 1. So I have a slope here of $1.75. $1.75x, don't forget your variable or it doesn't count. Elijah Sweetwine. All right, now, if this is increasing by $1.75 each week, if I go back one place where x is 0, y is just going to be 0 as well. Which makes sense because if they're starting to save money, they should start out with nothing. Now, who is saving more money each week? How do you know? I know that Antoine is saving more money each week because the slope is larger. Likewise, Carla is only saving $1.75 each week. So, Antoine is saving 25 cents more per week. Now, how do you know that? I know because the slope of this graph is larger than the table, which means that Antoine is saving money at a faster rate. All right, let's move on. All right, guys, believe it or not, scientific notation didn't go away. You're going to see it on your benchmark. So let's go ahead and review some word problems. Ms. Sudler is loading boxes of math tests into her car. Her car weighs 3.3 times 10 to the 5th when it is empty. The math tests weigh 1.4 times 10 to the 4th. What is the total weight of Ms. Sudler's car with the addition of the math test? Well, if I go through and read this again, I see that her initial weight is at 3.3 times 10 to the 5th. That's how much her car weighs without the tests. And I know that the math tests weigh 1.4 times 10 to the 4th. And I want to know what the total weight of Ms. Sudler's car is with the math tests on board, which tells me that this operation is going to be addition. Now, when I add in scientific notation, I do care about my exponents. So I have to remember my good friend Lars. I look immediately and I see that my exponents are not the same. So I'm going to have to make them the same. The way that I do that is I remember my good friend Lars. You always keep the term with a larger exponent. So I'm going to go ahead and move my decimal place on my second one place to the left, which means I can add 1 to my exponents. This should be familiar. So my new problem will be 3.3 times 10 to the 5th plus 0.14 times 10 to the 5th. Now all I have to do is add my coefficients. I'm going to add 3.3 plus 0.14. Make sure you line up your decimals and fill in your zeros. I'm going to be left with 3.44. So the total weight of Miss Sudler's car will be 3.4 times 10 to the 5th. Now, I'm going to double, triple check and see, is my coefficient between 1 and 10? Yes, it is. 3.4 is between 1 and 10. That's my final answer. Let's do another one. All right, Mr. Solney and Mr. Walther have decided to quit their jobs and become carrot farmers. Sounds like a nice life. In 1 year, Mr. Solney harvested 7.3 times 10 to the 3rd pounds of carrots. Mr. Walther harvested 5.5 times 10 to the 2nd pounds of carrots. How many more pounds did Mr. Solney grow than Mr. Walther? What I'm interested in here is how many more pounds did Mr. Solney grow? How many more tells me that this is going to be subtraction. And again, I know that if I add or subtract in scientific notation, I got to remember Lars, because that allows me to move my exponents. You always keep the one with the larger exponent, so I'm going to move 0.5 one's place and add 1 to my exponent to make it the same. My new problem is 7.3 times 10 cubed minus 0.55 times 10 cubed. Now, since my exponents are now the same, I can just go ahead and subtract my coefficients. So I have 7.3 minus 0.55, line up your decimals, and fill in your zeros. Now, I can't take 5 from 0, and I can't take 3 from 5. So I'm going to go next door and borrow, and, whoops. I can't take 5 from 0, so I'm going to go next door and borrow, make this a 10. And then I'm going to go ahead and I can't borrow 5 from 2, so I'm going to go next door and borrow, turn this into a 12. So I have 10 minus 5, which is leaving me with 5. 12 minus 5, which will leave me with 7. 6 minus 0 leaves me with 6. So my new coefficient is 6.75 times 10 to the third power. So my last check here is to make sure that my final answer is in proper scientific notation. My coefficient is between 1 and 10, so this is my final answer. All right, guys, that's going to be it for me today. Let's go ahead and practice.